D. And there, okay, let me grab that. All right, I will share my screen and we can look at this together. So applications of derivatives, you're kind of really into the heart of this first semester of calculus. The first thing here, it says to basically just put in t equals 0 into the equation. That's that because they're saying that it started in 1935.
Okay.
So p equals 1 over 1 plus 3e to the 0.
And that's e to 0 is 1, right?
Right. So this becomes 1/4. And
Oh,
so it says
25%.
25%. Yeah. And then the long run, what they're really asking is, well, what happens in the limit as t goes to infinity? 1 over 1 plus 3e to the minus 0.0275t. So as t goes to infinity, this e to the minus, maybe we haven't covered that, e to the minus x, limit as x goes to infinity, e to the minus x, this always goes to 0.
Mhm.
So this e part goes to 0, so it becomes 1 over 1 plus 3 times 0. So it goes to 1, which I guess it's 1 because it's not saying a percentage there.
Okay.
Are you allowed to use a calculator? Do you think this
Yeah,
is
yeah,
like
we're all using calculators for this.
okay? So the next part, you're setting p equal to 0.5,
Okay.
and if you're graphing it, like that's your y1 and the other one's your y2. So I'm going to graph it and then I'll snip in what I find here. What is this? Wow. 0.0 e minus 0.025. All right, I gotta adjust my window here. I'm not seeing anything useful at the moment. Oh, there it is. Okay. Why isn't this giving me what I want? All right, 0 to 100, we'll say. And then the next one is y equals 0.5. So you set them equal, and I'll snip this in. You can see where it happens here. It really kind of fine tune my window to get this. But let me snip it in here. You'll see that you can see they intersect there at 39.95, essentially at 40 years later. So we'll say 1975 because that's 1935 plus 40, 1975.
1975. All right. And now, when is the proportion of land used for farming increasing most rapidly?
Yeah, so they're saying like when is the second derivative 0? Where is the inflection point? Boy, that's not great. Wow, I can't believe they're asking that. Okay, so the first derivative is what we need. So the first derivative, if you look at this this function, so p equals 1 over 1 plus 3e to the minus 0.0275x. So p prime, okay, this is really 1 plus 3e to the minus 0.0275x to the power of -1. So it's really a power rule derivative. -1, 1 plus 3e to the minus 0.0275x to the -2 power, and then you have chain rule. So you have 3e to the minus 0.0275x, but then you have to take the derivative of this part, which gives you minus 0.0275. So it's a pretty complicated, pretty sophisticated derivative.
Oh yeah, it's a loaded one. I think
And
I
then
saw this in class today.
yeah, and then you gotta actually
Plug the stuff in.
well, no, you graph this and see where the min and the max is. So
You just plug into Desmos and just look.
I'm gonna graph it. Yeah, I mean, because you really are supposed to get another derivative. That's product rule, and it's quite messy. But let me see if I can get where I can do this here for you. Okay, so -1, this to the -2 power, and boy, I hope I took the derivative correctly. And then it's this again. That's a lot of repeat of stuff. So it's 3e to that times minus 0.0275, like that. And oof. So it does also have a max at 40. That's interesting.
And about 40. Okay.
Oh, well, and so the year is 1935 plus 40, so 19. So it looks like it's the same answer. Which I don't know how you. Yeah,
No
let me know.
script.
Yeah, so I could snip it in, but it basically, it maximizes right there, and
Mhm.
then you're like, okay, there it is. All right, so does that take care of that question?
Yeah. All right. Here's the next question. I'll have to scroll down because it's a multiple whatever question.
All right, let me grab first part here. All right, if you want to scroll down, can do this next part. Okay, let me share my screen. All right, so if you're seeing my screen, it wants the average rate of change, the AROC, if you will, and average rate of change is just the slope. Average rate of change is just the slope. So from 0 to 5, you got to get P of 5, which is 222. So it's that second number there, minus P of 0 over 5 minus 0. So that we're going to get that number. This is one decimal place. If you've got a calculator handy, that number is going to go here in this first position. For the next one, the same thing. It's from 61 to 68. It's going to be 1710. I'm sorry, it's going to be 1724 minus 1710 over 68 minus 61.
Mhm.
So do you have a calculator available, or do you need me to do this?
I don't have one on me right now.
All right, so 222 minus 95 over 5, that's 25.4. Then the next one is all right, it's just 2. Sometimes when I type these in, I say, well, I already know the answer. It's 14. Okay. By early April 2003, the ever increasing rate, what is the earliest day which the rate had begun to slow? T equals blank, which corresponds to, okay. So what they're kind of asking here is like, well, when does the increase between like points, when does it get when is the individual slope finally getting smaller? And so to do this, I mean, it's 2003 blank corresponds to. So we're gonna say something like T equals, and we're gonna pick one of these numbers based on that, and then which corresponds to some year. What is in this box over here on the right?
Correspond.
I don't know what is this box right here for.
I'm not sure, which corresponds to says March, April, May, and then to the right, I'm not sure what it says.
Okay. I'm a little unsure how to proceed here, but because we're gonna pick one of the times based on a calculation, but I don't know where t equals, okay, zeros. I see. So yeah, I get it now. The t equals 0 is March 17th, and I guess this is the month, and then we put in the day. Okay.
Yes.
All right. So boy, this is not fast to do. I wish they just gave you a function. So I've got to like check the slope between each point. That's the strategy here. So I got to enter all the points here, or you could be guessing, I guess. All right, so 95. All right, so it looks like it would be try 12.
Try 12. Okay.
Yeah, we definitely need some feedback on this. It's either 12 or 19 is what I'm seeing here. I can't really decide whether it's what they're actually. So it's probably I'm sorry, it's probably, or it's 26. Let's try 26 actually. I don't know if you've already entered that.
So a t equals 26.
Yeah.
All right. So t equals 26.
And I don't know, just choose something for the drop down there.
So should I guess which month it is, or do we already know which month it is?
So it's going to be probably in April.
Okay.
And then the actual day depends on that t value. So just now for this drop down, I don't know what you can choose there, but
Oh, never mind. It says it's not appropriate because the concavity of the data changes over time. Exponential functions do not have a limit. Exponential models do not reflect real life.
yeah, I don't know. You can pick one of those.
Yeah.
It doesn't. So the inflection point occurs near t equals 19 is what it looks like from what I'm seeing. And we need that before we can do this one. And then the limiting value of p, that's predicted. They're saying like, well, how far does it go? It goes to 1760.
All right, so 19 and then p equals 19 too.
Probably.
All right.
Well, no. You have to put 19 into the model.
Oh.
I'm sorry. It's going to be 800 is what it looks like. Based
What
on the
did we
data
put?
point.
So what did we put next to April for 2003? Which one was it?
I'm not, it's based on this value here. So if it's truly 26, it's 13 days later. So let's say April 13th.
April 13th. Okay. I'll submit it. All right, the thing next to April isn't correct.
You'll have to share your screen at this point for me to be more helpful on the rest of this.
Apologies. Here we go.
There's too many things going on.
All right, can you see it?
Yeah.
All right, and let me.
So if the 26 is right, you can go with April 14th now. Maybe because it's 26 days after that. I don't know what to tell you to put there because if you look back in the data, when p is 19, or t is 19, p is 800.
Hmm.
So I'm not sure what to suggest.
Maybe. Just kind of keep trying. What about the 12th? Okay, the 12th works. All right, I guess we just don't know this one. Let's give it a little bit of time to load on up.
Okay. Yeah, I mean, this is can you scroll down past C? Okay, so they just want you to put that in for the equation. Okay. All right. This here. So we got a bunch of questions here. All right, let me share my screen. Try to make some sense of this. All right, so it says that suppose initially 6 people have the virus. So that means that when t equals 0, p equals 6. This right here is the value of k. And they're telling you that the limit as t goes to infinity is 3000, which essentially becomes L over 1 plus 0. So they're giving you information here to be able to answer this. So when t is 0, you get p equals L over 1 plus c. And so that equals 6. I'm sorry, that equals 6, not p. That doesn't help you because you got too many variables. But when you go to infinity, you get L over 1 plus 0 equals 3000. So that tells you that L is 3000. Then when you put that back here, it's like, well, 3000 divided by 1 plus what number equals 6. Okay. 3000 divided by 500 gets you to 6. It looks like C is 499 and K is 1.78. So will you try those before we move much further?
All right.
And then part C is like just plugging those in. It's 3000 over 1 plus 499 e to the minus 1.78
This fair correct.
t. Okay. So you said that did work?
Yeah, it worked.
Okay, so once you get the equation to do part D, you just graph it, and hopefully you can get the right window to make it look the way you want.
So 3000.
And I got a horrible window here, so hopefully. Wait a second. You said that was correct?
I'll check it again. Let's see.
It was good. I see what the issue is. I'm graphing, getting the wrong stuff here.
Yeah, this is all correct.
Okay. So you're looking for the inflection point.
Mhm.
So we have to again take a derivative of this and set it equal to 0. So it's the same as the previous problem, but let me actually do that another way and see if I can do this a little quicker. Oh, I see. It looks like it's roughly 3.5. What does it want you to round to? One decimal place? See if 3.5 will work for T.
And that is correct.
So then to get the Y value, you just put 3.5 into that function there. So T equals 3.5 and then P equals 3000 divided by 1 plus 499 e to the minus 1.78 times T. Try 1513. Oh, it says nearest 100 people, so maybe go 1500. That may.
That's correct.
All right, great.
Okay, here's the last one. This one probably should be quicker.
All right. Can you zoom in at all on that? So the limiting value is look like the number that it approaches horizontally. So it's somewhere between 30 and 40. Maybe it's 35. It's really hard to tell. That's the limiting value there. It's whatever the Y value is. So it looks like it's 35,000. Jack, are you?
Yeah,
you're there. Okay. Just wasn't sure if you were following. No, it's already in terms of thousands, just 35.
Oh, in the middle.
Yeah. Okay. And then the next question, that's the one we're having so many issues with from the previous problems, is like you have to figure out where does the inflection point. So for me, I guess I want to say it's at 16. If you look 16 and change from concave up to concave down. So maybe try that for T.
16.
And then the N, yeah, we can, so that took it for N. So N is right around 20,000, just the Y value there.
All right. Yeah, this is the only one that.
Yeah.
I
think I recommend that you be content with this one.
Yeah.
I don't know that I'm going to be able to give you
Wonder if anything. Did I do that? Oh, I just guessed.
Great.
Why would it be 1600 though? That doesn't make any sense.
I
just
don't know.
doubled it.
I don't know. It's not reasonable, but who doesn't matter.
Yeah, I got it somehow.
Yeah.
Well, thank you very much for your time.
Yeah.
I really appreciate it.
You're welcome. Thanks, Jack. I'll see you next time.
You have a nice day.